What is the limit as x approaches infinity of x minus ln of x? Both x and ln of x tend towards infinity and grows without bound as x approaches infinity, so we have an infinity minus infinity indeterminate case. However, we know that x grows faster than ln of x, so it's reasonable to assume that x minus ln of x would approach infinity as x approaches infinity. The intuition is that since we're subtracting a term that grows slower from a term that grows faster, x will dominate, and the ln of x term won't matter as x approaches infinity, so the entire x minus ln of x expression grows without bound. But this is just the intuition, and I would like to show this formally. So here's what I'm going to do. I'm going to let y equal the limit as x approaches infinity of x minus ln of x. So y is the limit we're trying to find, and if we take the exponential on both sides, we get e to the y equals e to the power of the limit as x approaches infinity of x minus ln of x. And if we use the chain rule for limits, e to the y is just equal to the limit as x approaches infinity of e to the x minus ln of x. If we use the property of exponents, we can rewrite the limit as x approaches infinity of e to the x over e to the ln of x. The exponential and the logarithm cancels out, so the expression in the limit just becomes e to the x over x. The limit as x approaches infinity of e to the x over x is in the infinity over infinity indeterminate form, since e to the x and x both grow without bound as x approaches infinity. So we can actually use L'Hopital's rule. Since the derivative of e to the x is equal to e to the x, and the derivative of x is 1, the limit as x approaches infinity of e to the x over x is the same as the limit as x approaches infinity of e to the x over 1, and this is just equivalent to the limit as x approaches infinity of e to the x. The limit as x approaches infinity of e to the x is clearly infinity, but I'm just going to take the logarithm on both sides before I compute the limit. So if I take the logarithm on both sides, the left-hand side becomes y again, and the right-hand side becomes ln of the limit as x approaches infinity of e to the x. Using the chain rule for limits, we can bring the ln inside the limit again, so the right-hand side becomes the limit as x approaches infinity of ln of e to the x, and that's just clearly equal to x. So the limit becomes the limit as x approaches infinity of x. We originally let y equal the limit as x approaches infinity of x minus ln of x, so we can replace the left-hand side with the limit as x approaches infinity of x minus ln of x. The limit as x approaches infinity of x is just infinity, so we can conclude that the limit as x approaches infinity of x minus ln of x is infinity, which is the original limit we were trying to find. This is a reasonable conclusion since x grows faster than ln of x.